I'm having trouble finding any gray wire or brown wire of a heavy enough gauge. So I'm going to change up the colors some. This doesn't look bad. Purple. Purple, but it's still in purple with like a pink stripe on it. So the first wire that I'm going to repair is going to be this this red heavy gauge wire. This is the main power feed. Runs up to the actually when I originally took it apart, this wire was spliced to another wire. That one was going right to the rectifier, and the other wire was going up to the red connection on the switch box. What I'm going to do is I'm going to run this wire right to the rectifier, and then I'm going to have another wire coming from the rectifier going to the switch box, and that'll bridge it in the same fashion. They got these little copper sleeves, and strip the wire back and put it into the sleeve. Now if I can get it hot enough and flow solder inside there, it'll make a good strong connection electrically and mechanically. Alright, that seems pretty good. So I'm just going to leave this wire long for now, because I don't know yet how short I'm going to need to cut it. And the other thing I'm going to do is I'm going to get some heat shrink tubing and slide it over this and cover this all with heat shrink tubing. One down, 5 to go. All right, this black water. This black wire is smaller gauge than that last wire. So if I were to use I don't have any really small copper sleeves, and if I were to use a copper sleeve on one of those big copper sleeves on this, I'd have to fill it with a lot of solder, and I end up with a really big bump, and the heat shrink tubing wouldn't seal around it really well. So what I'm going to do with this one is I just kind of wrap the braids around each other in a kind of a half twist, and if I'm delicate enough, I should be able to flow solder right into the braid of the wire. The trick is to keep enough pressure on the iron so that I'm getting a good contact and transfer of heat with the tip. But at the same time, I don't want to break the mechanical connection that I just have precariously put together here. But I've got to get that copper hot enough to melt the solder. There we go, so that it flows right into the braid. I should have used some flux on that. That wire is oxidized badly. Like, it's not really flowing into the braid. You can see it just kind of sitting there on the surface. It's actually making a connection right now, but it's very unimpressive to say the least. Tight proximity to this damn other cable. Yeah, let me get a little bit of flux. Try that. Well, the good news is the flux worked, and the solder flowed nicely into the braid. The bad news is my wire came apart. So I've got all this solder flowed into this half of the wire. Virtually none on the other half. All right. All right. So what I did there was I flowed solder into each braid individually using the flux, and then I laid the wires parallel and just flowed more solder. So it's not as strong mechanically as it could be, but it will work electrically. It's a little bit bigger than I was hoping, but as long as I can get, see, the thing I'm aiming for here is I'm looking for the size of heat shrink tubing that's gonna fit over this wire so closely so that when it shrinks it makes a really good tight fit. The problem is, like, if I get this all the way down there, I know it's not going to go over that connection, so I've got to go a size up from this. Naturally, the problem with the red stuff is it might not shrink down enough to make a nice tight connection onto the wire. Well, I'm almost done. I didn't video doing all of these because it was basically just a repeat of the same thing I had been doing on all of these. One of the things I did do is I doubled up on the heat shrink tubing on these. First I went with the smaller diameter, and then I went over it with a larger diameter. And the reason why I did that is to strengthen these up a little bit. I found that these wires, these existing wires, were really flimsy, and they don't have much strength to them. So I want to kind of beef up that mechanical connection there. So I was just getting ready to use the heat gun and put on the last couple pieces here. The other thing I ended up doing was I changed the color of some of these wires through necessity. I didn't have any gray wire this gauge, so I went with some green wire that I have. I changed a cup. I forgot what color this was. It's now blue. I think it was yellow. This is just a short wire that goes over to the starter solenoid, so that's why this one I actually made out of an existing wire I had with a connector already on it. I made it a little bit longer in case I have to cut that connector and change it. I'm going to verify all of my pinout. This piece is a little short, but it's what I've got left of that length, so I'll use it just the way it is. 2, 4, 6. Got six wires, not counting these two, which I believe is correct because I think originally I had 7, but that was because this large red wire actually went to 2 locations. It branched into 2. It was a splice and it branched into 2 other wires. So that's looking like that's going to be doable, which is nice because of the high expense of a replacement wiring harness. But I got another problem. Something I totally forgot about. So last night I was down here rebuilding the wiring harness here, and battery in the camera died, and I was just talking about how I had discovered something I had completely forgotten about that I really wish I had addressed before I put this thing back together to the point that I've got it now. And the problem is that I had totally forgotten that this special bracket right here that holds that plug assembly in position was held in with two small bolts. One threaded in over here. You can't see it because it's behind this boss from this camera angle. But here's where the other one threaded in, and it snapped off. And I remember thinking, oh, okay, well, I'll just deal with that when I've got it all apart. And lo and behold, I never did do anything about it. Totally forgot about it. And then when I was going to do the reassembly, I realized, oh, that's not supposed to be there. So last night, what I did off camera was I tried to remove that remainder of that bolt. It's almost impossible to grab onto. I tried clamping onto a vice grips, and it's tight enough that I can't really get any twisting action in there either because of the fact that it's so close up against here. I've got no room. I tried heat. First, I just tried heating here. That's what this discoloration is right here. This is where I was actually holding the torch right there, propane torch, and getting a lot of heat, hoping that I could actually heat this up. I tried PB Blaster. I tried PB Blaster and didn't have any effect. Then I tried heat in conjunction with PB Blaster. I even tried taking a punch and putting a punch squarely on top of the broken bolt and tapping it, giving it that mechanical shock that sometimes helps with heat to break these things free. And so far, no dice. Now, I haven't tried it today since it sat overnight, and let's see if I have any luck. I'm kind of doubtful that this is gonna. I mean, that was so tight. It's deceiving. It almost seems like it's turning, but it's not. That's not. It's just the twisting of the vice grips. So that's not going to happen. All right. So what I'm going to try and do now is I'm going to use some magnification to see if I can't position this punch as close to dead center on this thing as I can. Okay, because the way that bolt has broken, there's a ridge on there that is barely perceptible with the naked eye, but is not going to allow me to center that punch. So the first thing I'm going to do is I'm going to try and grind off the very top of that and make a little flat spot. Alright, this is a left-hand twist drill. So this drill actually drills when it's being turned in the opposite direction. So I'm going to stick this in my cordless drill, and I'm going to run the drill backwards while I'm drilling. The reason why I'm going to do that is because sometimes the heat of the drilling process will actually start to free up the broken stud and the broken bolt. And if you're turning it backwards, it can actually have the effect of actually unscrewing the bolt right out of what you're trying to remove it from. Ideally, I would want a bigger size than this, but unfortunately, I'm kind of limited as to the amount of left-hand drills that I have here in the shop. And I do want some cutting lubricant on this. Try a little tap magic. Oh, here's some tap magic for aluminum. Just spilt more down inside the motor case than I didn't get on the drill. It's hard for me to see how straight this is going in. Yeah, of course, now I can see that that's off center. Now that I've already started it, I can't really turn it at an angle to try and bring it back on because, well, yeah, that's not good. That's right near the edge there where I don't want it. I can't enlarge that hole now any more than that without breaking out through the side wall. I've never had much success with these. But let's try a screw extractor. That's not gripping. That ain't doing it. Hopefully I could hit the center this time. Using a larger punch this time. Better. Normally, if I could angle this enough, I'd work at getting that right in the center. Can't angle it out though. I'll try and tilt the drill just a little bit before I start. Still looks like I'm off center. Oh, I can't go much lower than that. I'm going to get a regular drill. There we go. Get some of that lubricant on there. Well, that screw extractor's useless. Well, that's either slipping or turning. One of the two. What's it doing? It's slipping. Slipping! What if that was bottoming out? Alright, that's the bottom of the bolt. It's gripping good. But now, I feel like I'm on the verge of having the easy out snap on me instead of turning the bolt. Ah, oh, damn it. My hole is off center just enough that I might already be into the threads. Well, I decided the way I'm going to handle this is I'm going to drill that hole out larger, and I'm going to put in this 1/4 stainless steel cap screw. This is like 3/16 diameter, which I don't know what that corresponds to. Fine thread, but there seems to be enough meat in that housing that I should be able to get away with putting this in there. And this doesn't have to be super tight because the way that that clamp works, and by using stainless steel, hopefully if I need to take it out at some point down the road, I'll be able to get it out. So I verified that this is a 1/4 bolt with my rusty pitch gauge. And I know that I already checked on my chart here. I need a number 7 tap drill size. And just verify that it's that this is a number 7. Sometimes they get put away in the wrong place. And it is. And it's a good sharp drill. Next thing I wanted to do was find myself a tap handle that like it's still got leverage on, but is small enough to clear spinning in here. This one seems to be fine. Of course, the trick is trying to start it straight.
You know, Rod Stewart used to say the first cut is the deepest, but that's actually not true when it comes to taps, anyways. Man, what the heck's going on there? Yeah, something's wrong here. Why is that stopping? Feels like it's gonna break. Something's wrong. Probably little pieces of the old bolt. Shavings. The outer skin of the old bolt somehow still stuck in there. So it went a little bit further that time. That's better. That should be plenty good enough. That's how you pick up a stainless fastener when the magnet won't stick. Alright. Does anybody remember how this goes in? Oh, it must go in facing up because it's got this flat rubber piece right here that actually sits in a groove down here. So that makes that easy enough to figure out. Easier said than done. Alright, let's see. What are you gonna do? Tilt this back first? You pain in the butt. Putting this in was a lot easier. I mean, taking it out. Oh, I wonder if I turn it. Does that do it? Do I have to rotate it into position once it's in? Let's see. It doesn't seem to be doing anything either. That ain't helping. It can be done. It just takes some gnarly twisting and turning and strong fingers. Whew. Okay. Oh yeah. Not so fast. I forgot. I have to modify my clamp because a 1/4 diameter will not fit through there, folks. Normally I would probably want to do this on the drill press or the milling machine because this is a open slot that I'm trying to drill a hole into. It was already so close to 1/4 inch. I wonder if it matters. Ooh. Oh, that's a good way to snap that ear right off of that. Alright, stop screwing around. And on this side, I can put in the original little, I don't know, 3/8 or whatever the hell this is. 3/8. All right. That'll work.